Hooray, it's a planning question all about pendulums. Okay, so this is a combination of classic question type with classic question context. Okay, we're planning an experiment to determine the relationship between time of one swing and the length of a string. Okay, sort of shown a couple of examples of these before. Please do have a go at the question, and when you're ready to go, have a look at my answer and see what you think. Okay, so this is the usual setup. Now, I've said before, so we just keep this in your mind. We've got the string, we've got a stand, we've got a clamp, and we've got a bob. Okay, we're being asked to do our usual thing of measuring variables, telling us how you measure variables, etc. So, as ever, I think I put a little caveat. I've given an answer here. I may have missed something, all right? But what I'm trying to show you is the way to get at least sort of 4 or 5 marks in these questions, because I think the mark schemes do tend to vary, all right? And if I've missed something in my own answer, I'm very happy to admit it, because I've done it very quickly. Okay, please, when you're writing them, think about some basic ideas. So, what are the things we want to do here? Firstly, I would identify the independent variable. It's going to be the length, and you're going to measure it using a meter rule, okay? I've decided this time to go even more detail. Writing out in my planning, I'm going to say what I'm going to measure and some things that I could do a bit more detail there. Okay, so the length, we're interested in the length, we're also interested in the period, okay, the time. And what I'm going to do is I'm going to use a stopwatch. I hope I've written that down somewhere else, okay, and I'm going to measure multiple swings of those, and that'll come in later. Control variable, I'm going to use the same angle each time, so when I pull this thing to the side, and I'm going to make sure that's measured using a protractor. Even more detail, I could be saying that I'm not just going to use a protractor, but I'm going to make sure the angle is quite small, because that's really important here, but it's not required. And then I'm going to use the same bob, right, with the same mass, same material. I'm going to go over the top here, same shape, same radius. Give as much detail as you can. We're going to repeat for multiple L values, and we're going to draw a graph. Now I think, you know what, would this get marked? I think a marker, if you wrote nothing on the following page, they would be able to give you some marks here. CIE is not a nasty marker, all right? They are trying to give benefit of the doubt. So sometimes students get to this point, run out of time, and they'll look at this, okay, they might try and give some marks, but I've written it out as well. Okay, so, all right, here's what I've said. I've said hang the pendulum from the clamp, measure the length of the pendulum using a ruler. I then said displace pendulum by a constant angle theta, which can be measured using a protractor. So notice here I'm stating a control variable. I'm saying how we measure it. We're going to let the pendulum swing 20 times, okay, and measure the time for 20 swings. Now that's where maybe I need to look at the mark scheme again. Maybe I wouldn't get the mark there. Maybe I need to say stopwatch. Maybe I need to be really explicit. Be explicit here, okay? Make sure you say how you measured everything and give any details, okay? We're going to repeat to calculate an average time, okay? And then we're going to change L 5 times, each time measuring the average time. Notice I'm not going into loads of detail here. I'm doing bullet points. It's really simple and easy to follow. Okay, I'm going to note the results in a table. Okay, with length in meters. Doesn't have to be meters, could be centimeters, could be millimeters. T in seconds, capital T in seconds. You must have the units here. One thing I do know from marking these papers is that you need to make sure you have the units in both your tables and your graphs. The graph is going to look like this. Plot a graph of time in seconds versus length in meters. Okay, now I think I've done enough there to get, you know what, I'm going to be nasty myself, 6 marks. I think I should have said something about the stopwatch, but I've definitely put something about the control variables. I've identified my independent variable, my dependent variable, my control. I've said that we're going to measure this using 20 swings and divided by 20. I've got my graph, I've got noting the results in the table. It's the quickest route that I can give you to getting, you know, up in the top level of marks in these kind of questions. My hope here is that by seeing more of these, you can see that actually all you have to do is read the question, right? Firstly, it says here you are trying to determine the relationship between these two things, the time and the length. So that's your dependent, your independent. The question already states what relationship you're looking at here. You then need to think about what control variables, okay? But yeah, hopefully you can see here that control variables are fairly simple, okay? Same bob, same angle, think about the experiment before you write it down, and try and do a bit more than what I've done. Name everything that you've measured and how you've measured it. Okay, that should be getting us into that sort of 6 or 7 mark bracket.